Bismillahirrahmanirrahim. We are still in this techniques of solving differential equation. We mentioned before that we have different methods to solve a first order differential equation, and separation of variables is one of them. And we gave a couple of examples in the last part. And in this part, we are going to give more examples how to solve differential equation using separation of variables. And our first example is this one. Y prime minus 1 plus x multiplied by 1 plus y to the power 2 equal to 0. And we need to find the solution of this differential equation. It means we need to find y. The function y equal some function written as a function of the second variable, which is x in our case. So y prime minus 1 plus x multiplied by 1 plus y to the power 2. And we say that in this method, separation of variables, we need to separate the variables x from y. So y prime is written as dy by dx equal to 1 plus x multiplied by 1 plus y to the power 2. I'm going to multiply the equation by dx. So I will have dy equal to 1 plus x multiplied by 1 plus y to the power 2 x. Now we have this variable, which is, or this part, 1 plus y to the power 2 in the right hand side. We have to move it to the left hand side, which means I have to divide by 1 plus y to the power 2. So I will have 1 divided by 1 plus y to the power 2 dy equal to 1 plus x dx. Now in the left hand side, we have only y and there is no x, and the right hand side contains only the variable x, there is no y. So we separated the variables, we separate x from y. Now we can integrate the left hand side and the right hand side. The integration of 1 plus y to the power 2 dy equal to integration of 1 plus x dx. The integration of 1 over 1 plus y to the power 2 is equal to tan inverse. Equal to integration of the right hand side will give me x plus 1 half x squared. And since this is indefinite, we must have constant c. So it is a plus c, or y equal to tangent of x plus 1 half x squared plus the constant c. And this is the solution of the differential equation. Y equal to tangent of x plus 1 half x squared plus the constant c. Let's take one more example. Number 2. Y minus dy dx cosecant of x equal to 0, not cosine, cosecant of x. To find the solution for this differential equation. So let's try to separate the variables x from y. Separating the variables, I will have minus dy by dx multiplied by cosecant of x equal to minus y. Or it is dy multiplied by cosecant of x equal to y multiplied by dx. This minus with this minus will cancel, and we multiplied by dx, it will go to the right hand side. I will have y multiplied by dx. Now dividing by y and cosecant of x. So try to divide by y multiplied by cosecant of x. Because I have y and cosecant. Cosecant in the left hand side, y in the right hand side, I will divide by both of them. Y multiplied by cosecant of x on the left hand side and the right hand side. Then I will have 1 over y dy on the right hand or on the left hand side, with y, and 1 over cosecant of x dx in the right hand side. Now integrate. I will have integration of 1 over y dy equal integration of 1 over cosecant is equal to sine of x. This one equal to sine of x. Now the integration of 1 over y equal to ln of y, or ln of absolute value of y, equal the integration of sine is minus cosine of x plus, since this is indefinite, plus the constancy. So the solution is ln of y equal to minus cosine of x plus the constant c. And that will be the solution for this differential equation. One more example, number 3. E to the power y plus x squared e to the power y multiplied by y prime equal to e to the power y multiplied by x. As we did before, we need to separate the variables x from y. For the left-hand side, we can take e to the power y as a common factor. I will have 1 plus x squared, y prime will be written as dy by dx equal to e to the power y multiplied by x. It's very clear that e to the power y on the left-hand side can cancel the e to the power y on the right-hand side. If we divide it by e to the power y, this will be cancelled. Now multiply by dx, we'll have 1 plus x squared dy equal to x dx. But we have 1 plus x squared on the left-hand side, so we have to divide by 1 plus x squared. I will have dy equal to x divided by 1 plus x squared dx. Now integrate. We have integration of dy equal to integration of x over 1 plus x squared dx. Left-hand side will give me y equal to integration of x divided by 1 plus x squared. This is integration by substitution. We can take the denominator to be u, 1 plus x squared, and then integrate. We will have 1/2 multiplied by ln of 1 plus x squared. And since it is indefinite integral, we must have the constant c. So this is the solution for this differential equation. Y equal to 1/2 ln 1 plus x squared plus constant c. And as I said, this is integration by substitution. Substitution. So the solution is equal to y, or y equal to 1/2 ln of 1 plus x squared plus the constant c. And take just one more, the last example. Number 4. Have y to power 3 multiplied by x to power 4 plus 1 dy plus x to power 3 multiplied by y to power 4 plus 1 dx equal to 0. First step, separate the variables. I will have y to power 3 multiplied by x to power 4 plus 1 dy is equal to minus x to power 3 y to power 4 plus 1 dx. Now divide by x to power 4 plus 1 and y to power 4 plus 1. Divide by this one and this term, or bracket, y to power 4 plus 1. I will have y to power 3 or y to power 3 divided by y to power 4 plus 1 dy equal to minus x to power 3 divided by x to power 4 plus 1 dx. This will be the form after we separated the variables x and y. Y to power 3 divided by y to power 4 plus 1 dy equal to minus x to power 3 divided by x to power 4 plus 1 dx. Now integrate. I will have y to power 3 divided by y to power 4 plus 1 dy equal integration of minus x to power 3 divided by x to power 4 plus 1 dx. This is integration by substitution. And I will have 1 over 4 ln of y to power 4 plus 1 equal to minus 1 over 4 ln of x to power 4 plus 1 plus the constant c, or it is just ln y to power 4 plus 1 equal to minus ln x to power 4 plus 1 plus 4c, or just I will say c1. If you multiply by 4, I will get this form of the solution. So it is ln of y to power 4 plus 1 equal to minus ln x to power 4 plus 1 plus constant c1. We just get rid of the 1 over 4 by multiplying by 4. That will cancel 4 on the left-hand side and right-hand side, or in the first term of the right-hand side. So the solution is ln of y to the power 4 plus 1 equal to minus ln x to the power 4 plus 1 plus the constant c1. So this is the idea of solving differential equation or separable differential equation. Just small reminder, the form of the separable differential equation is h of y dy by dx equal to d of x, which can be written as h of y dy equal to d of x dx. And you can see this equation, it can be written as an equation of two terms. H of y dy dx minus d of x or plus d of x equal to 0. I have only two terms. That's why we can separate the variables. Some other equations we will have in the coming part, three terms, in which that we cannot separate the variables. We are going to use different techniques that will be integrating or integration factor techniques. That will be explained in detail in the coming part. So that is for today. And this is how to find the solution for separable differential or differential equations.